And welcome to the beautiful auditorium here on campus at Full Sail University. And for those of you that are joining us online, welcome to the 2017 Web Design and Development Degrees Showcase. My name is Chris Burke. I'm the program director to the Web Design and Development Degrees here, and it's my great pleasure to be able to present these showcases to you. So keep in mind, these showcases will happen about every month just before our graduations, and they're designed to present to you a plethora of industry experts, as well as students that are rising up through our degree, sharing all of their insight and technological wisdom. So today is no exception. If you have questions and you're joining us here in the auditorium, please raise your hand, and we'll have a microphone run around to you, so that way everyone else in the auditorium can hear your question, as well as those that are joining us online. So for those that are joining us online, if you would, please direct your questions to the chat box there on the right side of your screen. I believe we have a moderator somewhere here in the auditorium. Adam, there he is. That'll help get those questions answered for you live. Okay. So today I'm very excited to bring out our presenter because I believe a lot of us that are in attendance today are interested to learn more about what it takes to put websites and web applications online. These days, our sites and apps are being built and leverage what we refer to as microservice architectures. And then being able to put these out online, or as our friend and actor Vince Vaughn would say, on the line. We call that a deployment strategy. So, here to share with you a little bit more about deployment strategies. Please help me welcome to the stage our friend coming to you all the way from high above downtown Orlando, Florida. He is the technology director of Purple Rock Scissors. Please put your hands together for Mr. Jim Powell.
Thanks, Chris. All right, before we get started, I want to talk about a couple things. One, this is a very dry presentation in that the humor that's injected throughout is very dry. So if you ever see something that you think was meant to be funny, it probably was, and it's okay to laugh. The next thing is, there are people here in the auditorium. There's also people at home. I'm going to ask a couple times questions like, raise your hand if you've ever X. If you're online or you didn't put deodorant on today, it's okay if you abstain from that. Those are actually designed to get you thinking about the question rather than actually participating. Cool. All right, so what we're talking about today is microservice architectures. And I know that the main audience that we're talking to today is mostly going to be from a development standpoint. And some of the nitty-gritty type of people that really need to get down into the weeds of how we're going to take all these web applications and web designs and websites that we've built and get them running on the internet in a nice, scalable fashion. So the biggest thing to understand about this is like a 10-day workshop, and what we're going to be doing is a 45-minute lecture. So I'm not going to get super far into step-by-step tutorialage or anything like that. I believe tutorialage is now a word. And we're not going to get too deep into specific names or tools or brands of different products. If you want to, however, at the very end, I'll put my information up on the slide. You can always get in contact with me, and I can help you walk through some of those things, give you some ideas, some concepts, some places to start. All right, so those are the general disclaimers there is laugh when you feel like you need to laugh, don't feel like you need to raise your hand, and overall just learn something. All right, so there's a little bit of context that we all need to understand when we're talking about the word microservices, or the two words put together. And that is, it's coming from something else. Just like anything in technology, or really anything in the way that humanity progresses, is there was something that came before it. And what came before it is not bad. We've just found a different way to do it that's better in most instances of how we do it today. So those two different things are a monolithic architecture. That sounds like a very derogative thing. When you say that something is monolithic, you're talking that it's huge and hard to handle. So that term is fairly new because it's actually made and designed to make you feel bad about it right from the beginning. The next thing is the microservice architecture. And the microservice architecture is almost the complete opposite of the monolithic architecture, and I'll tell you what that is in a moment. So just for the sake of pure ambiguity, we're going to call the monolithic architecture MA, and then we will call the microservice architecture MA. Thanks. All right, so everything works better with examples. So you're a concrete person. Jim, stop talking about all these concepts and abstract ideas. Here's a real-world example. We have a product that's called Giffen. This is not a plug for that. It's an iPad-based social photo booth. And the problem that we have today with all of these different platforms and services that we offer to clients and companies and consumers is that it's not just one thing anymore. It has to be multi-platform, multi-channel, all these big words that we always use all the time to describe something that can't just be in a single box. So in this case, Giffen, we have a bunch of different things, and I'll just take a quick minute to explain what it is. We have an iPad app that runs. People walk up to it, they tap the button, takes 3 GIFs, turns it into, or takes 3 images, it turns it into an animated GIF, and you can share it online. That sounds very fun, and it sounds very sociable, and in fact, it is. However, there's a lot of things that have to happen behind the scenes to make something like that happen. So we actually have a bunch of different systems in the mix that go through that. So we have the actual iPad app. The iPad itself doesn't do a lot of the work. It has to go up to an API. The API is the one that actually stitches everything together and puts logos on things and moves things around and posts them. Then we also have the photo feed. So of course, after it goes online, you want to be able to look through all of the different photos. So there's an application that does that. There's a customer portal so that when people get their Giffen, they can change colors, upload logos, and things like that. There's also an admin panel so that I can go in and remove offensive GIFs, and it does happen quite often. And then also an inventory management system. One of the things that we do is rentals, so we have to know what we have in stock, what we don't have in stock, and what availability looks like. There's a web service that actually does all of those things. So when we first started with this, we had 2 options, either MA or MA. So we're going to look first at MA. These are the pros of a monolithic architecture system. There is a single tech stack. So if you are a PHP shop, if you are a Node shop, if you're a Ruby shop, you have this one tech stack that everyone in your office or everyone in your building, or now if everything is around the world, then around the world, they only need to know this one thing. And they only need to be experts at this one thing. So then you have a single code base. So again, this sounds really nice. You have one place that all of your code lives. You can share code between different things. And everything can talk to each other just kind of natively. You have a single server base. So like we said before, if you're a PHP shop, that requires certain server requirements. Requiring requirements, that's good. So basically, you have a server that's going to run a web server, that's going to run a PHP interpreter, and your stack is going to look the same across all of these different things and services that we just talked about. What that looks like in practice then is, I made this chart, and I know it's really nice. Just hold your applause till the end, though. So we have those 5 pieces that we were talking about before, and all of those pieces are living inside that one box. That one box can be a physical box. That can be a server inside your closet. Would not recommend that. That can be a cloud-based virtualized server. That can be a distributed system across a bunch of different servers. But the idea is that it's all living in one place, and all of those functions are being accommodated through that one piece of architecture. On the flip side, we have the microservice architecture. This is getting very complex. And the reason that we're just now getting into this, you're probably thinking like, but this is kind of like gluten, right? Has it just become an issue? Has it always been there? Like, why is it just getting big? It's always been there. The way that we interact with it is changing. So the same thing here. Microservice architecture has always been there. We've always known that sometimes it might make sense to separate things out in this separation of concerns or responsibilities that you're always hearing about. But it's been hard, very, very hard. And the reason for that is because normally that introduces multiple tech stacks. So let's say we started off as a PHP shop. Now we've got to get .NET guys in the door, and now we've got to get this lady that works on Ruby on Rails to come in. That gets very expensive from a business standpoint. So up until recently, when we started introducing the idea of more of a full stack or a versatile development system, it's been really hard to find people that would be willing to. What you have to do at that point is find that better way, find a couple better ways, and actually weigh it out. A lot of people have the habit of just saying, we're going to automate right off the bat. That might be a mistake. Why don't you do it manually twice, find out exactly the steps that you need to do, and then actually look at how much time it's going to take you to automate it. If you can perform this function in 2 minutes and you have to do it 5 times, that's 10 minutes. If it takes you 45 minutes to write a script that's going to do 10 minutes worth of work, it's not worth it. So automate, but automate responsibly. There are a bunch of different ways that you can do that, especially when we're talking about web development. You have things like Gulp, Grunt, Webpack. You can write your own build scripts. You can use the NPM system to do build scripts. All of those are ways that you can do that. They all have their pluses and minuses, advantages and disadvantages. You can find those on Stack Overflow. I also have suggestions too. I'm just not going to actually tell you about those today. And then the next thing is make it portable. So we finally get to the crux of all of this. Thank you for that 30-minute introduction, Jim, to whatever it is that you're going to be talking about today. I feel so much smarter. All right, so we're here. And basically when I'm talking about portability for a web application or a website, what I'm talking about is the ability to develop and run that product in different environments. If you've been around in development for a very long time, you're going to say something like, wait, what? Because the old adage is, if you have this web product, you need to be developing in something that closely mimics your production environment, and you need to be staging in something that closely mimics your production environment. Because how are we going to know if it's going to run on that other system? Right? There's an answer. It's later. All right, so here's an example, so real-life example of the need to be portable across different things. We have a product that we're working on for a client. In the real world of product development, all of the utopian perfect world scenarios don't exist. We can try and find them, we can try and replicate them, but all of those are extremely expensive. And when you look at things from a business standpoint, they just don't make sense. So we have to find these middle grounds and these common solutions to actually solve all these problems. So looking at this, we have our MacBook set up, where we're actually going to be doing the development. We have a whole bunch of different build tools that I use on there. Let's say I'm using Gulp, and let's say that I'm using NPM for package management, maybe Composer. That's all set up on my local environment. Everything is running, and it's beautiful. I got a bunch of RAM. I got a huge hard drive. So when I develop things and I push things to a server that doesn't have as much, is it still going to work? I don't know, we'll find out later. Then we go into a QA or a test environment. This is actually sitting in the closet because only 3 people use it. And because only 3 people use it, it has way lower specs, and that's fine because it's not going to get a lot of users, so that's cool, so we use that. Now we're talking about going and sending it up to a staging environment. This is very, very important when it comes to deployment. When you're talking about actual production-ready environments, you have to have a staging environment. People call it staging, people call it UAT, that's user acceptance testing. People call it a whole bunch of different things. But the idea here is to stage the deployment to make sure that you don't break everything. And if you do break everything, you will figure all that out in the staging process. So in this environment, again, it's very important that this environment mimic the production environment almost exactly. So we got it as close as we could in this example. We have 2 different cloud virtual machines that are load balanced and talking to each other. And they have pretty decent specs, pretty close to the production environment. We can't possibly replicate the production environment in a staging environment because we would lose our shirts. So expensive. So we got as close as we could. And then in the production environment, we have this whole scalable cloud-based system that can spin things up and spin things down, and traffic spikes come in and go out. So it's a very different setup there, but still pretty much the same. This right here, it's not so bad. It's really not so bad. We're looking at Mac OS, which is a Nix-based system. We're looking at Ubuntu and CentOS and CentOS. These are all Linux distributions for those 2. So we're looking at these things and we say, these are all compatible. So we can write it all natively. This is my least favorite word in development, by the way. That's why I always put these guys around them. Natively. So we can write this on Mac so that it runs on Mac, but it also runs on this Linux and that Linux and uses all the cores or doesn't use all the cores. And everything should be fine because we wrote it natively. Cool. In reality, here's what it really looks like. Again, we're running into money issues, and you always will in the real world, is we brought in 3 more developers because we bit off way more than we could chew. Yeah, this is real life. So looking at that, we got a guy coming in with Mac El Capitan. That's the older version. Did anybody else notice how they changed the Mac OS X, and then they also changed the capitalization so that it looks more like iOS? I just noticed that when I was making this. So anyways, so they have a different version of of Mac OS. Not a big deal, right? Wrong. It's actually a huge deal. The different versions of Apaches that it shipped with, they're different. The way that it handles PHP, if you install it based on the base, is different. So there's a lot of changes that you're going to have to do to get those two people in sync on those. Then we have Ubuntu. We got the old school guy coming in. He's like, I got my Ubuntu box. I just need to use that. I understand it. I don't understand anything else. And then Sally comes in. She's got a Windows laptop. What are we going to do with that? So, hey, you know what? We could buy her a $2,800 laptop and all the dongles that she'll need, and we'll somehow figure out how to get her an escape button. Yeah. So maybe there's a better way. Again, there is. So in this case, probably the best thing to do. There's another thing here called remote development. Again, completely different talk. Don't want to get into it. But something like virtualization. The idea of virtualization is very simple / complex. So here's how it works. We have those 4 developers, and those 4 developers are sitting there, and they're running on one thing. So I've actually pared it down to 2 in this just for brevity. So looking at, we have the Mac OS person, that's this guy, and then we got Sally on her Windows 10 machine. So what we do is we take all of those specs that we're going to be using in that production environment, in the perfect world scenario, and we recreate them inside the computer. So the files are in the computer. Yep. Not many people got that one, that's fine. So what we're doing is we're saying inside of this Mac OS Sierra, there's a computer running that looks exactly the same as the computer that's running inside the production server, and inside the staging server, and inside everybody else's development box, and inside the test box. And maybe we just want to spin up a new environment just to check something out real quick. It needs to mimic all of those things. So portability is not making sure that it runs on different environments for the code's sake. It's making sure that it runs on different environments for the people's sake. So everyone can just grab this thing and run it. That means that once you get this new box, we'll call it a box, it's a computer inside a computer generally, that you need to build it. So let's say you get your brand new laptop, you open it up. Dude, you're getting a Dell. Does anybody get that one? It's fine. Okay, that was good. So it's just like getting a brand new computer, only it's not. There's some very, very common mistakes you can make here. You say, okay, we're starting the project. You know what? I'm going to spin up this box. I'm going to throw these things. I'm going to throw these things on it. I might use these things later. I'm going to put these things on there and do these things. Don't do that. Don't do it live. The way that, or the thing that you need to keep in mind is to make it portable, which is what we're doing now. Remember, this is the whole, like, Jim finally got to what he was talking about, is this portability. To make it portable, it needs to be scriptable and repeatable, this setup process and this provisioning process. So basically what that means is, if you could write down every single thing that you did when you got your brand new computer, if it got hit by a bus, you could just rebuild it, right? And you could rebuild it pretty quick. You might have to wait for some downloads and things like that. But because you made it repeatable and you actually wrote a script, it was just a personal script or a people script, to run through all of those steps to rebuild it, it's definitely rebuildable. It's repeatable. You could build 14 of these tomorrow with the time that you have because you figured out the formula and you figured out how to do it. If you just go willy-nilly and start doing things live, then you're going to break stuff. And it's also going to be a lot harder to get Sally on the project with us because we have to remember everything that we did to set up that computer inside a computer. So there are tools for that. So if we're going to use something like Docker or Vagrant, which I'll get into some specifics on those two later and what makes them different, you have Docker files and Vagrant files that can help with provisioning. They can say, base the box off of an Ubuntu box using this version. Please install Apache and PHP. Then when you spin up a new box using that methodology, it'll be exactly the same box that's running somewhere else, unless you do something live. Unless you do something live. The next thing to keep in mind there is single responsibility. This is the whole point of this whole microservice architecture, is single responsibility. So when you're spinning this thing up, if you're like, you know what, this server needs SSH on it, this server needs FTP on it, this server needs a web server, let's put a mail list server on there, let's make it a mail server. You're adding bloat to this system. Each system should have its single responsibility, and if you're not comfortable with that, go back to your monolith. It was supposed to sound more nasty than it was. All right, and the next thing is to use the files, Luke. This one makes more sense if you read it on the screen than if I say it out loud. So the idea behind this is inside of these virtualized environments, there are different ways to interact with them. And in a development environment, stay out of the box. Literally keep out of box. If you go into the box and you make changes, we're breaking this whole provisioning thing that we talked about earlier. It's just not going to happen. So you can't do that. Instead, you can version your configuration, and you can put all of the things that need to change inside of your version control. So here's an example of an actual project where you have the application, code goes here, this is all the things that you're used to writing, this is all the things that you're going to write anyway. But pull out pieces that need to change and pieces that need to be configurable and put them in your code. So now when you push this new version of this application, any changes that need to happen on the computer that runs it can be part of that version of the application. All right. So the next thing is when you're onboarding, you can always answer this question like this. Hey, Jim, how do I get started on this project? I can actually say, it's in the README without being a jerk. Because remember, I documented everything, and I wrote it down. I ran the noob test, and I made sure there was a bus factor that was actually good. All right, so now we're talking about scalability. We're getting close to the end. Thanks for bearing with me. All right, so the idea behind this microservice thing gets more complicated here, but this is the coolest part about it. Coolest part. So everybody wake up and let's do this. All right, so looking here, this is a real-life example. The numbers are a little different. Trade secret, don't ask me. Of what's actually running at any given point in time. So for GIF, and remember this is social photo booth, it has peaks, it has different things happening. So on a normal daily basis, we got some redundant API servers running, and then we have all these other pieces that are just sitting there. Now we have this huge event out in California, tons of people are using it. We're gonna scale up, and we're gonna make this so that it works a little bit better and a little bit faster. I'm not going to scale up the whole thing. Again, this becomes very, very monolithic price-wise. So I'm going to scale up the pieces that I know that I need. I can also set up auto-scaling, which happens very easily nowadays with things like AWS. They also brought the internet down a couple days ago, so maybe we won't talk about them too much. So these APIs, we scaled that up a little bit. We also scaled the feed up a little bit because we don't want it to be slow for people when they're taking pictures and looking at pictures. But then there's another way that we might actually have traffic spikes. We send out our email blast with coupons, 20% off your next rental. All our repeat customers come back in, they grab in the portal, they're uploading pictures, they're doing these things and that. It's a completely different use case for scaling up. So I want to scale up the things that I need to scale up, not everything at once. So remember we talked about MA before. We switched to MA, but now we're talking about MA. Looking at this, normally, it's probably going to sit around like this, and everything's going to be running and everything's going to be fine. And then we say, you know what? We have to scale up a little bit because we're getting more and more feedback and more things. So we're going to spin up another completely new server. We only really need it for the API side of things. The rest of that is wasted bandwidth, wasted space, wasted file storage, wasted computing power. So then we say, OK, that other thing happened, and now we need to scale this thing up. So we have to pull up another server that's doing all of those things. These servers are monolithic in nature. They're huge. They're expensive. So hopefully you can see some of the benefits there. Deployment is the easiest part, said no one ever. Deployment has never been the easiest part, and it probably never will be, because what we're doing here is we're taking a system that works and replacing it with a system that we think works. We are almost always a little bit wrong about that, and we always have to go back and make changes and fix things. So there are a bunch of different types of deployment that we can use. These are the ones that you probably want to go back and review and look at because it's cool stuff. These are oversimplifications. This is not exactly right. I before E was what you were taught until the 3rd grade, when somebody was like, well, that's not completely correct. Christopher Columbus discovered America. Well, so here are some deployment types that we can use. One is called rolling. Rolling deployments are very often used on scalable architectures like Elastic Beanstalk. It comes back to Amazon again, sorry. So the idea behind this is we have these 2 servers that are running, and they're both running version 1. So we push this up, it's been running, now we got some changes we want to make. So a rolling upgrade will do this. Take down the 2nd server. It's okay, we still have the other server, everything is fine, nobody panic. Then we're going to update the second server with version 2. We're going to run checks and we're going to run tests to make sure that everything is kosher and everything is doing everything that it should, but the world cannot see this server yet. Once we verify that everything is good, we're going to point the entire world to this server and we're going to pull down the other server and repeat the process. So that's the idea of a rolling deployment, is we're taking the fact that we have multiple servers, we're taking advantage of that, and we're doing things in small chunks, checking everything along the way to make sure everything is good. If you have more than 2 servers, that does mean that maybe half the country is going to be on one version and half the country on the other version. So that's something that you have to keep in mind and consideration. Another type of deployment is called a light dark deployment. This is a more immediate version of deployment. It's a little bit riskier sometimes because it is a switch that you flip, and everybody is now looking at the new version, so problems can arise pretty quickly. Light dark would be, we have this idea of a production environment and a staging environment. We put everything into staging, we tested it, everything looks good, so why not just call that production and swap places? Let's go back and forth between these two so you can see that the only thing that's happening is we're switching production and staging. That's it. After we do that, we can update staging so that it's new and it looks just like production, and now we just swap them back and forth every time we have to do a deployment. That's called a light dark. Generally, you specify one set of resources as light, one set as dark, and then you just swap them back and forth. This is extremely common in systems where you have very large server farms or you have a lot of different active users at any one point in time. Because it is a switch, everybody immediately moves to that other version that you already know is working because you've tested it heavily in the staging environment. The next one is the downtime model. This one is the most common. It's the easiest one to do. Remember how we have virtual servers, boxes and boxes? We can have a virtual server that all it does is have a maintenance notice on it. Switch it over. So now everybody says, hey, the stuff is down, come back in 5 minutes, when we all know it's going to be 3 hours. And then behind the scenes, we can change that out to be version 2. And then once we've verified that it's correct, and everything is running, then we can release that version 2 to the world. So this is downtime. The other one is called fingers crossed deployment. I don't know if that's a technical term, but here's how it works. It's version 1, and then we switch it. This is the most common type of deployment in the industry and in the world, and it's something that I think we should all move away from. All right, so the very last thing we're going to talk about is virtual options. There's virtual machines, and there's virtual environments. This is the part that all these getting started tutorials will not tell you. They are very different. When we're talking about a virtual machine, we're talking about a full box inside a box. So your computer has a desktop, so does the virtual machine. It has RAM, so does the virtual machine. It has a hard drive, so does the virtual machine. It has cores from the processor, so does the virtual machine. So it's a box in a box. It's generally dedicated and separated from your actual box. If you're running a Linux box inside your Mac box, they have a hard time communicating with each other because they're completely separate. That's called a VirtualBox, and Vagrant do basically that. VirtualBox is something that will allow you to take resources and put it on another box inside the box. The pro of that is it is super freaking portable. So when Sally comes in and she's like, I need to get going, you get a zip drive. You guys remember zip drives? Maybe not a zip drive. You get a thumb drive, you load up your box on it, and you give it to her. Now she has a clone of your box, she's up and running, everything is fine. The con for that is they can be, if you do it incorrectly, or you do it correctly and it's not the right use case, resource hogs. You're saying that, hey, I would like to give this box inside my box half of my RAM. That means you don't get half your RAM. You're having to divide it between these two pieces. Then the other piece, a virtual environment. This is what Docker is. So that was a VirtualBox and Vagrant, and this is Docker. It's faster deployment, and it has less resource usage. I don't want to get into what makes it different. There's a virtualization layer. You can share the resources between the two different things. But there's a steeper learning curve because it doesn't have a virtual network adapter. It's using the same IP address, the same port allocation. So it's harder to get people to see what's inside that Docker container than you would normally think. So, hey, Jim,